Hello, I'm Chris Athanas. I'm a KMP developer. Tech support's coming out on Tuesday for that. Today, we're going to be getting into the topic of technical debt. Now, I took a break from software development. When I came back, this was all the rage. Right? When I came back around 2017, 2018, around that time, I got super back involved with it. Before that, I'd done other stuff, but that was when I started picking up on this term. Technical debt being thrown around. I was like, what is going on with this term? It's like, and then people use it in all kinds of different ways for all different contexts, all kinds of different things. It was just super big deal. So I decided to go. It popped up on my feed. One of the this guy, Ward Cunningham, originated the term technical debt. So who originated the term or the concept of technical debt? So Ward, at the time, was defending his case to his boss about the cost. He wanted to do this refactoring that made his code cleaner. We're going to listen to him in a second. Refactoring his code to be faster for him and his team, to work in the future. And he was trying to explain it to his boss in terms of a metaphor. A financial professional doesn't know anything about code, in the financial would easily understand. He did this as the example was not technical debt. The example was how you communicate. It was meta. Ward was trying to be meta with it when he talked about this. That look, when you're talking to your customers and your stakeholders, you have to put it in terms that they'll understand. Not that the metaphor is completely perfect in all cases, and it was never meant for that. So let's get into it. What did he? Let's go hear from Ward. All right, this is from his channel, Fair Use, and we're gonna start about right here.
First, we live by. An important idea is that we reason by analogy with the metaphors that have entered our language.
Right. So he was into a book. Let me just start from the beginning. He was into a book.
I became interested in the way metaphors influence how we think after reading George Lakoff and Mark Johnson's Metaphors We Live By. An important idea is that we reason by analogy with the metaphors that have entered our language.
Right, so you're saying people live in metaphors.
I coined the debt metaphor to explain the refactoring that we were doing on the Ycash product. This was an early product done in Digitalk Smalltalk, and it was important to me that we accumulate the learnings we did about the application over time by modifying the program to look as if it had been, as if we had known what we were doing all along. And
it's refactoring to make it look correct and look better, not just the first pass through. So let's talk about refactoring.
And to look as if it had been easy to do in Smalltalk. The explanation I gave to my boss, and this was financial software, was a financial analogy I called the debt metaphor. And that said that if we failed to make our program align with what we then understood to be the proper way to think about our financial objects, then we were going to continually stumble over that disagreement, and that would slow us down, which is like paying interest on a loan.
Right. So the thing was that the idea was paying for things that was a better way, but you're going to pay for it anyways. That's what he's talking about, the technical debt. So we'll get into it.
With borrowed money, you can do something sooner than you might otherwise, but then until you pay back that money, you'll be paying interest. I thought
that's the financial side, right? That's not how it actually, the metaphor extends out, but that's the financial idea, right?
Borrowing money was a good idea. I thought that rushing software out the door to get some experience with it was a good idea, but that of course you would eventually go back, and as you learn things about that software, you would repay that loan by refactoring the program to reflect your experience as you acquired it.
Right. So he was trying to tell his boss, hey, we can go fast and get this stuff out there to show that we can make progress on this, but we're going to have to go back and fix all that stuff because it's really not meant to be, it's extended like we are looking to do. So we have to go pay that debt back. That's what he's trying to say.
I think that there were plenty of cases where people would rush software out the door and learn things, but never put that learning back into the program.
So when that first rounds, that was all we were doing, just making stuff, throwing it away. That was it was extremely hard to maintain any of this stuff because the languages weren't set up for it.
And that by analogy was borrowing money, thinking that you never had to pay it back. Of course, if you do that, say with your credit card, eventually all your income goes to interest and your purchasing power goes to zero. By the same token, if you develop a program for a long period of time by only adding features and never reorganizing it to reflect your understanding of those features, then eventually that program simply does not contain any understanding, and all efforts to work on it take longer and longer. In other words, the interest is total.
Right. The maintenance costs definitely start to overwhelm the projects, and that's most of the cost these days is maintenance costs. That's lots of studies will show that.
You'll make zero progress. Take longer and longer. In other words, the interest is total. You'll make zero progress. A lot of bloggers, at least, have explained the debt metaphor and confused it, I think, with the idea that you could write code poorly with the intention of doing a good job later, and thinking that that was the primary source of debt. I'm never in favor of writing code poorly, but I am in favor of writing code to reflect your current understanding of a problem, even if that understanding is partial.
Yeah, that's the idea.
If you want to be able to go into debt that way by developing software that you don't completely understand, you're wise to make that software reflect your understanding as best you can, so that when it does come time to refactor, it's clear what you were thinking when you wrote it, and making it easier to refactor it into what your current thinking is now. In other words, the whole debt metaphor, or let's say the ability to pay back debt and make the debt metaphor work for your advantage, depends upon you writing code that is clean enough to be able to refactor as you come to understand your problem. I think that's a good methodology. It's at the heart of extreme programming. The debt metaphor is an explanation, one of many explanations of why extreme programming works.
I mean, that's one way of looking at it. But the idea that you're gonna have this debt that you can pay. Okay, so there's all these ideas around. So let's just go into it. Let's just make sure we would be slightly pedantic about this. So it's not an excuse to make things poorly or hastily. It's not the choices that are being made along the way. It's not deferring a decision till later. It's not an excuse to do something that you know should be done. This is the key word here. Not technical things that are not done correctly. So corner cutting is a bad idea, and not borrowing from the future. But you could so there is an idea like if you need to get an MVP out and you're about to collapse the company or whatever, or you just want to do a low cost solution, yeah, getting things out the door quickly and getting something up and going, even if it's not completely 100%, that's totally a legit thing. So, but you're going to have to address that at some point. That MVP is going to have to become production level at some point. You can't just put that into production. I've put the companies that have done that, and it's just not good. It was never meant to be that way. So, and that debt caught up to them to the point where they couldn't move anymore. So they had to fail. The company failed. So, overextending that. So what I've seen a lot of these bloggers he's talking about, you have to bring it to bloggers, is overextending the metaphor far beyond its original intent. So that is what's the big deal here. So how is technical debt different than financial debt? Let's just go down and be into it. So technical debt can't be leveraged for other investments like financial debt. It can't be structured for future tax advantages. This is the stuff that go. If you say to a financial person that it's debt, this is what goes through. This is what goes through your minds. Is they're like, this is their world they live in, right? This is the metaphors they know. So if you use a metaphor, make sure it's the correct one, or they know that there's a limited scope around it. So you can't be hedged against for future beneficial flows like financial debt can. It can't be transferred to another security investor like a financial debt. You can't do any of that stuff. So I'm assuming the popularity of this term exploded during the I'm going to read this, cheap and easy money days from 2010 to 2019. Many people got involved with the tech industry due to their ability to gain access to the cheap financing. Most of these folks have had very little or zero technical knowledge about how software is created, its inherent limitations, and the lack of coherent, repeatable processes. These people become captivated by a term they knew to explain something complicated and bewildering, like doing knowledge work. So they took so they got like kind of this. This is why this term became popular, I believe. So that's what that's about. So other than the idea of unwanted payments that will get much larger over time if you don't address it, so other than that, the rest of the metaphor is completely broken, and I think should be if you're going to use the term, make sure you explain this or show them this video or show them Warren's video. Warren's video. Okay, so let's go here. Okay, what is technical debt then exactly? All right, so technical debt, it's much more simple than interest and payments and all that stuff and debt, all that complicated crap. Technical debt is anything implemented with the best knowledge you have at the time you were writing it, the best knowledge with the best everything you know, bring it to bear. And as soon as you become aware of an obviously better solution, when technical debt occurs, when you become aware, it's like, oh shit, I should have done it differently. Like in my Fred's Road Trip Storyteller, I started off using this snapshot arrays, which were not thread safe. I didn't know that at the time. I thought they were. I thought everything was working on the Android side, in just under 500 markers. But as soon as I went over 1,000 markers on the iOS, I started getting all this race conditions, things partially updating, all kinds of big mess. So I became aware of it, and I was like, oh, I gotta swap it out for this state flow stuff. And I swapped it out, and now it looks like if you go look at the code after I swapped it out, you'll never see any of the remnants of that old snapshot array list thing. It's all gone. But you can go back and see what I changed. And I made notes and I did a video about it. But yeah, it looks like I never wrote it like way, and that was what he was getting at. Yeah. In all software projects, as time goes on, the set of knowledge grows, and unexpected and important things always come up that were impossible. This is like the financial guys. What? How do you not know? It's just a computer. It's like, well, it's because it's human activity. We don't really know all the things, and this is a very fluid environment. Things are changing. That's welcome to software. We can change it. That's why we like. So that's why we like it, because it changes all the time. That's its positive, and its negative side too. Everything's changing all the time. Unexpected important things always come up that were impossible to know at the beginning of the project. There's just no way to know some of this stuff, and there's a gap in what the code does currently and what a better technique comes now. So there was a gap when I knew that the state management thing I was messing up because this snapshot stuff wasn't thread safe. I was like, now I gotta go change it. And I put it off, and as I was putting it off, I was suffering through trying to do screenshots and stuff, and I was getting movie and trying to run it properly, and yeah, so I was paying that debt the whole time until I was like, okay, fine, I'll pay it. And it was actually a lot faster, went a lot faster than I thought. In that case, I got lucky on that one, but sometimes it's not the case, right? You can implement something and have 1,000 screens, and all of a sudden it's like, oh no, that thing's gonna break when after the user's on it for six days in a row, the seventh day some out of memory thing happens because you're got a memory leak somewhere, and then you have to go through all that. Oh yeah, you have to pay a big price for that. So yeah, that's why it's like sometimes it's we got to pay the price. We got to pay that technical debt, and that's knowing there's a better way, but you can't change it right now for whatever the reasons. So we pay it on the interest or the unnecessary costs on things that touch that code, or touch that piece, or just having to deal with it in some way. It doesn't have to be just code. It can be any part of the process that's completely inefficient and some other thing happens. Like when fax machines started coming online in the 80s, before that, people used FedEx to send everything. And that's how FedEx got a lot of their business initially. And when the fax machine came up, and people could start using just regular phone lines, that network exploded, and FedEx lost a lot of business due to fax machines. And so the technical debt was like, we're going to keep paying FedEx until we buy a fax machine, right? And figure out what those faxes is all about. And that happened, super fast. So that's what I'm talking about, was not just code. It's all kinds of things. Okay. Okay, so what is technical debt exactly? It's like needlessly paying for things we know there's a better way. When we build something with incomplete knowledge, we're bound to need to change it. And in the meantime, we pay the price in terms of wasted time and money and unnecessary complexity. So we have previous knowledge, current way of doing things, and that's the gap, which is the technical debt. When you become aware of it, that's when I was like, so it's like something you can't get ahead of time. It's only through the process. That's the other thing, is you can't buy it ahead of time. It's like, it's like you automatically get a fine in the mail. It's like, what do I get this for? Oh shit. Present knowledge, better way of doing things. So that's where the debt comes in. And yeah, that's what I want to say about that. And thanks for watching. I'll put the links to all the stuff.